Three-phase system of soil. Three-phase system of soil. Soil contains number one, soil solids. Number two, water. Number three, air. These three components can be represented by phase diagram like this. Phase diagram. First solids phase, then water and air. To understand the soil mechanics better, first we should focus on this three-phase system. See, right side of the three-phase system, we represent this with mass volumes. So volume of solids, and left side of solids it is mass of solids. Similarly, water, volume of water, left side mass of water, and again here volume of air, and this one mass of air, which is always we consider as 0, mass of air, because it is very negligible quantity. Now we need to define some basic parameters of soil mechanics. That is, first one is void ratio. Void ratio. It is represented by small e. Void ratio is defined as voids, volume of voids. See, volume of voids means this volume of air and water together is called volume of voids. So, volume of voids by volume of solids. That means we are comparing this voids, this entire, this air and water together, it is called, this air and water together is called voids. So, volume of voids by volume of solids is defined as void ratio. Void ratio. Now, another parameter, porosity. Porosity, it is eta. It is represented by eta symbol. Eta, that is volume of voids divided by total volume. It means total volume means this is the total volume complete. Volume of voids and solids together, it is total volume. So, volume of voids divided by total volume is called porosity. See, now we will see what is the difference between this void ratio and porosity. Void ratio we are comparing with volume of voids with volume of solids, whereas porosity we are comparing this volume of voids with total volume. So now, is there any relationship between void ratio and porosity? That we will see. If you see here, in this phase diagram, solids and voids. So this is, we are calling this as volume of voids, and this is volume of solids. This total volume is V. This total volume is V. Suppose if you take volume of solids as 1, in void ratio formula, E equal to VV by Vs. So obviously E equal to volume of voids equal to E. If volume of solids equal to 1, then E equal to volume of voids. That means VV equal to E, and total volume V equal to 1 plus E. Total volume V equal to 1 plus E. Now porosity will be volume of voids, that means E, by total volume means 1 plus E. So this is the relation, eta equal to porosity equal to E by 1 plus E is the one formula. Similarly, by manipulating this eta and E, we can get formula for E also, that is cross multiplying this, E equal to eta plus eta into E, or E into 1 minus eta equal to eta, and E equal to eta by 1 minus eta. This is the formula for void ratio. If you know the void ratio, you can find porosity, and also by knowing the porosity, we can find void ratio. So vice versa. These are two parameters, very important parameters, void ratio and porosity. If you observe here, void ratio E can be more than 1 also, as volume of voids can be more than volume of solids. E can be more than 1 also, but in porosity formula, volume of voids always less than V, porosity should be always less than 1. E can be less than 1 or more than 1, anything is possible. So E can be less than 1 also, either less than 1, can be either less than 1 or more than 1. Both are possible, E, but porosity is always less than 1. Then next parameter we will see what is percentage air voids. See, percentage air voids we will see in this phase diagram. This is volume of solids, this is volume of water, this is volume of air, solids, water and air, and this is total volume. So third parameter, we are defining percentage air voids. Percentage air voids VA. So VA equal to percentage air voids VA equal to volume of air voids divided by total volume into 100. So that is percentage air voids. And fourth parameter we will define as saturation, degree of saturation. Fourth parameter is degree of saturation. Degree of saturation, S. So S can be defined as this volume of water divided by volume of voids. This volume of air and water together is called volume of voids. So in voids, how much water is there? That is S. Suppose if complete water is there like this, all voids are filled with water, no air, solids and water. That means all voids, all volume of voids are filled with volume of water, then in this case, if volume of voids equal to volume of water, then degree of saturation equal to 1. Similarly, if all voids are filled with air, all voids are filled with air, that means total volume of voids is equal to volume of air itself. So if volume of voids equal to volume of air, there is no water, so S equal to 0. That means it is dry case. This is dry case. This is saturated case. Other than this, partially saturated case means S will be in between 0 and 1. So in partially saturated soils, partially saturated soils, S is lying between 0 and 1. 0 and 1. And one more parameter is there, that is fifth parameter, that is air content. Air content AC. That air content is volume of air divided by volume of voids. Volume of air divided by volume of voids. Now there is a relation between degree of saturation and air content. Relation between AC and S. We know volume of voids equal to volume of air plus volume of water. Dividing with VV, 1 equal to volume of air by volume of voids plus volume of water by volume of voids. Therefore, 1 equal to volume of air by volume of voids is air content plus volume of water by volume of voids is degree of saturation. So S plus AC is always 1.